Right, so I want to try to graph both of these just to get an idea of what they look like. So if you have a calculator that will let you change the log base, you can do that. So like if you have a calculator like the one I have here, you can type this straight in using that math button and looking at the table. If you don't have a graphing calculator or you don't feel like you know how to use one, you can always come see me for tutoring, or let's just go ahead and talk about it right now, another way we could do this problem. So if you wanted to, you could change this to exponential form. So instead of graphing log base 2 of x, this really means y equals log base 2 of x. So I could change this to 2 to the y power equals x. And instead of putting numbers in for x, I could put numbers in for y and see what I get for x. So for instance, I could put a 0 for y, and 2 to the 0 power is 1. So I know this graph is going to be at 1, 0. I'm going to put another number in here for y, like 1. 2 to the first power is 2, so that would make x2. So I've got the point 2, 1. The next one I might want to try for y is 2. 2 to the second power would make x4, so I've got the point 4, 2. Let's go the other direction. What if I would put negative 1 in? So 2 to the negative 1 power. 2 to the negative 1 power is 1/2. So you can see we would be at 1/2 negative 1. If I put in negative 2, that would make this 1/4. So you can see how this one is getting closer and closer and closer to this line, but never touching. But it's different from the first one, because this one on the top didn't stretch as much. So by changing it to the exponent power, you can kind of see how you would switch the input and the output in order to make your graph. Let's think about the domain and the range here. The domain goes from 0 to infinity. The range, negative infinity to infinity, because it keeps going down like this. The asymptote would be this line right here, x equals 0. Again, if you have a graphing calculator, you're welcome to put them in the calculator. Sometimes it's easier just to graph the exponential form. Let's do this one. So I'm going to change it to exponential form in order to graph it. So this would move this over to be the base, so it'd be 1/2 to the y power equals x. So let's make a table of values. This time it's easier if I put numbers in for y. So I'm going to start with 0 for y. 1/2 to the 0 power is 1. That looks the same. And then I'm going to put a 1 in for y. 1/2 to the first power is 1/2. I'm at 1/2, 1. Okay, let's try 2. 1/2 to the second power is 1/4. So at a fourth, I'm at 2. So you can see how this one is going to start doubling and getting really close to the line on this side. Let's see what happens when I put in something smaller than 1, or something smaller than 0, like negative 1. So this time I have 1/2 to the negative 1 power. And when we have a negative 1 power, that flips the base value. So this becomes a 2. So I have 1, 2, negative 1. If I put in negative 2, this is going to become 4. So this time it looks like this. So this is still a log function. Look where the asymptote is. The asymptote is at x equals 0. The range still goes from negative infinity to infinity. And this one, the domain, still starts here and goes this direction. So the domain is negative infinity to infinity. So you can see, just like with an exponential function, if it's like 2 to the x, it would be a growth function. If it's 1/2 to the x, it would be a decay function. So this being a 2 is going to make it rise or increase from left to right. The fact that this is a 1/2, it's going to make it decrease from left to right. All right, let's do a couple more. What do you notice about these two problems? So on the first one, this is log base 2 of x. So we have this thing right here, add 1. This time, the thing you're adding 1 to is the x. So let's see if we can see the difference between what would happen if I add 1 at the end or if I have the 1 with the x. Let's see what that changes. So let's start with this one, and I'm going to go ahead and change it to an exponent to graph it. So I'll start by moving the 1 over, and then making it into exponents form. So 2 to the y minus 1 equals x. So let's make a table of values. Now I want to be strategic about the values that I put in for y. I want to pick something to start off that makes this a 0. So my first y value that I want to try is a 1 in that spot right there. 1 subtract 1 is 0, and 2 to the 0 power is 1. So this one has a graph at 1, 1. Oops, put that at 0, 1. Okay, now I want to try something bigger than 1, like 2. 2 minus 1 is 1, 2 to the first power is 2. Okay, let's try another number for y that is bigger than, let's try 3. 3 minus 1 is 2, 2 to the second power is 4. Like that. Let's try a number smaller than 1. So I would have 2 to the negative 1 subtract 1 equals x. So 2 to the negative 2, which would be 1 over 2 to the positive 2, which is 1/4. So the graph goes to 1/4 negative 1. So this graph looks something like this. So the domain is 0 to infinity, the range negative infinity to infinity, and the asymptote is still x equals 0. Notice though this time that typically we have our first point at 1, 0, but that point has been shifted up 1 just like every other point. So just like all of our other functions, adding 1 at the end is going to shift the graph up. Okay, let's do the next one. So this time the 1 is inside with the x. So you can probably guess that this is going to not shift up or down, but it's going to shift to the left or the right. So let's take a look and see. I'm going to change this to y equals log base 2 of x plus 1. So now I've got to move 2 to the y power equals x plus 1. And now subtract 1 from both sides. So 2 to the y minus 1 equals x. So again, this time it's going to be easier for me to put values in for y and see what I get for x. So I'm going to start off by putting 0 because I like it when there's a 0 for the exponent. 2 to the 0 power is 1. And 1 minus 1 is 0. So I have a point at 0, 0 this time. Okay, let's try something bigger than 0 for y. So 2 to the first power minus 1. 2 to the first power is 2. 2 minus 1 is 1. Okay, let's try something even bigger. So 2 squared minus 1. 4 minus 1 is 3. So I have a point at 3, 2. I could try something bigger like 3. 2 to the third power minus 1. 2 to the third power is 8. Minus 1 is 7. So this point is at 7, 3. Okay, let's go backwards and let's try negative 1 for y. So 2 to the negative 1 minus 1. 2 to the negative 1 means 1/2 minus 1, which is negative 1/2. So this time I'm going to go negative 1/2 and down 1. Let's try negative 2. 2 to the negative 2 minus 1. 2 to the negative 2 is 1/4 minus 1 would be negative 3/4. So you can see how this number is getting closer and closer and closer to negative 1, but never touches. So it looks something like this. So this time, asymptote is going to be at x equals -1. If you plug your graphing calculator, it's going to look different though. Let me show you for those of you that are using the calculator. If I do log base 2 of x plus 1, and I want to put the parentheses like that, graph, this graph looks like it is stopping here, but it actually doesn't stop. It keeps going down. You just can't see it because it's kind of running into the asymptote with a digital line. But if I look at the table, I can clearly see, let's go down here, that once I get to -1, I have an error. And everything beyond -1 continues to be an error. So that makes -1 our asymptote. So this number inside here with the x is going to determine the asymptote. So this one's moved 1 to the left. So the domain now is -1 to infinity, and the range is -infinity to infinity. So we can see then that whatever the log base is, it doesn't matter what the number is down here, whatever value I'm putting inside with the x is going to determine the asymptote. So this one is going to have an asymptote at x equals -3, which is going to affect the domain. If I had log base 7 of x plus 5, let's make this one minus. X minus 5. That means that when I graph it, I'm going to move 5 units to the right, and that would be my asymptote. So the log function is going to look something like this with an asymptote at +5 because this was -5 inside with the x.